especially in the spring.
Yeah. Look at my water, it's 7.06 normal.
Okay. So this is what we're going to cover today. We're talking about moles, atoms, grams, moles. That's where the decimal number will come from. I mentioned this a little bit last year. They were called AMUs, atomic mass units. Then we're going to talk about those today using grams. Okay. You will definitely need a periodic table, and you definitely need a calculator. All right. Now, we have units in every discipline, and the units are designed for the specific discipline. For example, if you're an egg farmer, what is the typical unit? Dozen. Right? You don't use a ream because a ream is used in paper. Ream is 500. You don't talk about 500 eggs because it doesn't make sense. It's designed specifically around the egg industry. Can you have a dozen of something else? Yeah. Dozen pencils, a dozen sheep. It's just a number. Okay. In the chemistry world, and the physics world, and the engineering world, and in the molecular biology world, we have a unit associated with that as well. And that is called the mole. Now, mole comes from the word molecule. Okay, and what is a mole? It's just a convenient number. It's just like a dozen. It's just a number. It's a huge number, but it's just a number. So we can have a mole of atoms. We can have a mole of molecules. We can have a mole of sheep. Yeah.
So how many is it? Like how many of atoms is it? Or is it not defined?
No, it is defined. Okay, so a mole is equal to that number, 6.02 times 10 to the 23rd. So it's a really big number. Now, because it's a really big number, that means atoms and molecules are really small. Now, if we were to use dozen with atoms and molecules, it would be really big. So anyway, the physics, chemistry, molecular biology, 23. Huh? 23, yeah.
So the exact equation would be basically like what's up there times however many it is.
Yeah. So remember going back to unit 1, whenever we have a quantity like this, we can end up with a conversion factor. Now this is we're going to apply this to atoms, molecules, and electrons. And we're not going to use electrons in here, but we're going to use atoms and molecules a lot. Okay, so like unit 1, we were doing dimensional analysis. We're going to convert this into a conversion factor. So the conversion factor is I'm going to put atoms down, but it could very easily be molecules or electrons or ducts. It's just a number. And then every time we have a conversion factor, we have the inverse of it as well. So that means you automatically get okay, so for example, if we had Okay, so how many molecules are in 1.23 moles of water? This is a typical visual problem like we had in this unit before chemistry unit. Okay, so what's the 123 moles of water? How many? That's the key word. How many? Whenever you see how many, I want you to key into 602 times 10 to the 23rd. Now, the guy that discovered this name is Avogadro. So this is Avogadro's number, 602 times 10 to the 23rd. Okay, so we're given is going to be 1.23. I want you to put moles of what? Be water. And moles have got to cancel. Okay, so the moles cancel gives us number of molecules, the one-step problem. And so we are looking at how many sig figs for our answer? 3. Okay, so we have 1.23 moles of water. This is exactly like one on chemistry. Okay, let me ask a similar question. How many atoms of hydrogen? Remember, a molecule is H2O. Hydrogen is an atom of oxygen. Okay, so how many let's get what's 1.23 moles of water. That goes on the left. And how many molecules of water we're going to have? So we're going to use 602 times 10 to the 23rd molecules. Because I told you had 1.23 moles of water. So the only way to find atoms is to find the moles of H2O first. Then we can convert to atoms. So once this all cancels out, we have, and done the calculation, we have so many molecules of water. What do we need to multiply by now? Right.
Why would you say two?
Hydrogen atoms.
Yeah, so total number of atoms in hydrogen is 3 and hydrogen is 2. But you don't have, you can do it that way, or we can have a conversion factor. So there are 2 atoms, hydrogen, to 3 oxygen. Now, what is wrong with my setup here? Exactly. Molecules and atoms. So what needs to be on here?
One molecule.
Molecule. Okay. Now the molecules cancel. We're left with atoms of hydrogen. Now, let's think about this problem. Let's look at a bicycle. Bicycle has how many wheels? 2. How many frames? 1. So if we have 10 bicycles, how many wheels will we have? We have 2/3 bicycles. It's the same thing here. That's why we get 2 over 1. Yeah. And we take the water molecules apart. That's where we end up with the wall. Now, sometimes it's going on. For example, we had the same problem. Gold medal is just AU. So it's 1 atom. 1 atom. So the ratio is 1 atom, 1 atom. So we would say 1.23. That's what gold is, just AU by itself. We're going to end up with 740 times 10 to the 23rd atoms. So you have to look at what you're starting with. Do you guys get much green up here? Get much green up here? Yeah, there's a fair amount down right. Okay, all right, does these problems make sense? Okay. Now, what if we came up with a slightly different version of this? How many grams of water are in 1.23 moles? Now, this is a different problem. Notice up above here, we're talking about gold, water, and we always use another number. When we talk about mass, you cannot use one number. You have another mass relationship and mole together. And that relationship is from the periodic table. If we go up to the periodic table, okay, we sort of talked about this a little bit last week. Okay, so we have these numbers. This number means what? Atomic number, which is also what? Yeah.
Number of protons?
Number of protons, exactly. So atomic number and the number of protons are the same number. This number has to do with, if you took a mole of oxygen atoms, it's something that's 1/23 of them in the world. Remember, they're isotopes, varying isotopes. If you average the mass of all the isotopes, you end up with 16.00 grams. Okay? This is what the decimal number means, called the atomic mass. So the atomic number, atomic mass. That is the number we need to do this problem. Only we're going to use the molar mass of water, which contains 2 hydrogens and 1 oxygen. Okay, so we're doing 1.23 moles. And we need a grams per mole for water. You all know water formed as H2O. So we need to find the atomic mass of 2 hydrogens and 1 oxygen. Hydrogen is 101, oxygen 16. So the molar mass for water is 18.02 grams per mole. So every combination of elements is going to be because they're all different sizes. The number of them is the same. It's like we took a bowl of grapes and oranges. And 10 each. Each is going to weigh oranges. Oranges are bigger than grapes, but it's the same number. And that's why these numbers, the periodic table, are all different. Different stuff in each one of them. Okay, so to do this problem, we're just going to go 1.23. Sig figs in the answer. 3. Okay, so. And that's what we project all the elements found on the periodic table. That's the decimal number. And sometimes the periodic table, you'll won't see a decimal number, you'll see a number in parentheses. What that means is there are no isotopes. There's only one. Like Einsteinium is 252. Now, one of the reasons there's only one isotope is because these are all made in cyclotron. In cyclotron, frequently these are around sometimes microseconds, sometimes hours. The longer they're around, the more isotopes. They're very fast and disintegrate. Usually in one isotope. There's probably more. Really so fast. Okay, so now we have two conversion factors. We've got so we have 602 times 10 to the 23 atoms or molecules per mole and grams per mole. Now, the grams per mole, this is for all chemicals. Okay, so we're using the grams per mole. You have to know the formula. Looking at the number of atoms per molecule applies to gold, water, fat, sugar, raw. Okay? Where do you get that from? Yeah. Okay, so let's do some problems with that. Okay. How will we work this problem? How much does 1.23 molecules of water weigh? How will we work this problem? Well, first of all, what's the unit? Okay. What's our next step? The word weight. So what is this for? Bring it, right. So is there a conversion going to molecules? Right. Right. There's no direct conversion. Two conversions are we have number of atoms to mole and grams. Not grams per number of molecules. So, two-step problem. So the first thing we need to do is, if in doubt, convert to moles. Everything's related to moles. You're in a physics class, you're in a geology class, chemistry class, molecular biology class, it's moles, moles, moles. So how do we convert molecules to number of moles? What do we use? Exactly, Avogadro's number. Okay, so the molecules cancel. Now we have moles of water. We want grams of water. What do we need to use? Now, of course, moles have got to cancel. How many grams are in 1 mole of water? (1802). 2 hydrogens and an oxygen. 101, 101, 16 add up to 1802.
So why did you cross off the, where it says 1 mole?
Because we want everything to cancel except for math.
So 1 mole, 1 mole.
Yes. And this is moles of water too. We always want to associate, if we have a number, I want you to try to associate that with a given molecule. Because in a little while, we're going to go from one molecule to another molecule. And you need to make sure that the grams per mole are properly associated. Okay, so everything cancels except for grams, which we're trying to calculate. All right, so we're going to go 123 times 10 to the 34 times 1802 divided by 602 times 10 to the 23rd. How many sig figs are our answer? 3. Now, I frequently will use 3. And the reason why I frequently use 3 is I grew up with a slide rule. Slide rule for active. So my mind comes to a lot of things I do. And remember, got us to move. We said fix. All right, so the answer is going to be 3.68 times 10 to the 11th grams. That's a lot. Why do you think you did that? No, by 23rd.
Oh, right.
That's cement is so too. Yeah. So, and also believe it, the 23rd, 6 and 2. They didn't have that. What way did it? All right, so right here we go. 23. Now, the reason why I look over here. We get about 1.3. Just push the W. And the big one. So you know, 1.334 times ETL2 divided by 602 EE.3. All right, how many atoms are in 3.45 grams of water? So we've got, let's do one water. Molecular water. Okay, that's perfect. Okay. What's next? Remember, if in doubt, convert to mole. Mole is your hub for everything. So you're going to go from whatever to the hub, whatever to moles, then from moles to whatever the answer is. Okay? So think moles. All right? So you go from grams to moles. So grams needs to be on the bottom, moles on top. And water is 1802. Okay? So that gives us that gives us moles of water. What's our next step? Okay. Yes, but before that, what's the second? What does the 1802 correspond to? Does that correspond to anything else? This corresponds to the whole molecule of water. So that's the 1802. And that's what grams of H2O, not grams of hydrogen. And that means more than that corresponds to H2O. So here, then we find how many molecules that corresponds to. Because see, this is moles of what? I just got moles of water. Moles of water. So now we need to figure out how many water molecules do we have via the number. Okay, so now we have molecules of water. Now we can convert from molecules of water to atoms of hydrogen. So that's the two atoms, H to one molecule of water. Molecules cancel. And they're all done because everything's canceled except for hydrogen. Is everyone okay with the steps so far? And we have 3 sig figs. We're looking at the 2.31 times 10 to the 23rd atoms of hydrogen. I got 2305. Yes, 2.31. Okay. Now let's see how we're doing with what we're going to learn tonight. Okay, so we're doing pretty well here. Okay, we're going moles, number of atoms, grams per mole, grams per number of atoms. Now this is what we're going to be using. Hydrate. Hydrate means molecule of water. I'm going to heat it up really hot. Once we're effectively blowing hot. And that's going to drive off the water. And then we're going to get a percent water and move in formula. So for example, cupric sulfate is anywhere from 8 to 12 molecules of water. Okay, that big dot stands for hydrate. So cupric sulfate hydrate, that's the formula for it. Cupric sulfate anhydride and no water. A lot of chemicals are hydrates. And you have to calculate the molar mass of this is grams of copper, sulfur, 4 oxygen, 16 inches. That considered molar mass of water. So let's look at a problem where we're figuring out the I don't know how to do a dot. A big dot. That's called a glyph, and I don't remember how to do that. So we're just going to put, let's use a star. Good idea. Okay, so if we took 24.1 grams of cupric sulfate and functional hydride, that's the formula for hydride. There's no easy way to figure out how many waters are in. And we heat it to a constant. Then you heat it, by the time you weigh it, you heat it again, if the mass is the same, then it's more water. If the mass goes down, that means there's still water in it. So heat it to a constant mass. What's the resulting mass of the anode? How will we do that? Yeah, it's dry because why? Yeah, we drove off all the water. Okay, to do this, we need to know the percent mole ratio of copper sulfate dot 8 H2Os. Okay, so how many grams are in a mole of CuSO4? Well, we need the periodic table for that. Okay, so copper is 6355. Sulfur is 3207. Oxygen is 16. So that's 16 times 4 or 64. Water is 18.02, and we have 8 of them. So what is that? Now we're going to add all those up. So it's going to be 16 through 8. Okay, so cupric, sulfate, hydride is 303.78 grams per mole.
So all those combined is 1 mole.
Exactly. 1 mole of copper sulfate, 8 all together. That means we have 602 times 10 to the 23rd of them. Okay, so the idea here is we need to find the mass of Cu-SO4. That's when it's dried up, the mass of the copper sulfate. So let's look at the, we need the molar mass of just plain copper sulfate. So that's going to be that's going to be 6355, 3207, and the 64. Okay, that's 159.62. Now we're going to heat both those numbers in this problem. Okay, so how are we going to do this problem?
Better now.
I'm a little confused on, so the 303 number, that's all of it together.
The other number is the other number is named hydro. Well, what do you think? Are we starting with the 303 number or the 159 number? 303 because the 24 grams is of the hydrate. So okay, that gives us moles of the hydrate. What's the ratio between moles of hydrate and moles of copper sulfate by itself? So this is what we're looking at here. We're taking that now with heat to this. My goal is to figure out the mass of the hydrate. The mass of it. So this is your first exposure for chemical equation.
This is it's like the equivalent to what we did for that. Salt and water, you guys want.
A little bit. This is more sophisticated than that. That would just evaporate the water off. Here we're also evaporating the water off. In that sense, Okay. All right, so this is a chemical equation. We're going to be working with these guys the rest of the semester. So all chemical equations, we start with something called reactants. No exceptions. What you create from the reactants are products. So reactants, something happens. Now, you have to break bonds and use form bonds. In our case here, we're not going we're not really reforming bonds. Right? Okay, and again, this is why. Sometimes new products form. Basically, the atoms in the product reform, the red part reform that product. This side is different from this. The difference in this situation, all of that is broken off. What this is saying. From a balanced equation, from a balanced chemical equation, and we're going to have a whole bunch of stuff on how to balance an equation. Right now, this is already balanced. We have coefficients out front. And the coefficients are blank, that means 1. That's a real option. They're like mono optional. Same with this. There's nothing in front of it. All coefficients 1. So we have 1, 1, and let's make that. And 8. So if, only if now, if the equation is balanced, that means we have a molar ratio of product. Molar. We get that from the coefficients. So this is going to be a coefficient ratio. So this is what I mean. For each mole of hydrogen, 8 moles of water. 1 mole of salt. The coefficients are the molar ratio. moles come into play.
So is there a reason you didn't highlight or underline on the outside? Yeah, thanks. You highlighted and underlined on the sheet on the products.
Yeah.
But you didn't do that on the gap. Is there a reason why?
Yeah, because we emphasize one bound. So on the product side, we actually. That's why it's plus. Okay, this also is molecular ratio. So that means one molecule of copper sulfate hydride on heme will yield one molecule. Okay. So both molar and molecular ratio. What word did I not mention? Gram, not mass. Only moles and moles. Only. No exception. So. So this is going to be that's going to give us moles of the hydrate. And we're going to get the moles of the anhydride from the balanced equation. And what's that relation to the coefficient? One to one. For each hydrate, we get one anhydride. So that's a conversion factor right here. So 1 to 1. So we know the moles of one, we know the moles of the other. Now that comes from the balanced equation. And you can only get that from the balanced equation. So whenever we have a situation, we have a definition, we have a chemical reaction going on, it has to be balanced. Now you might say, why put that in there? It's 1 to 1. That's because the units won't cancel unless that's there. Now we have notice now here I'm actually canceling hydride. Yeah, yeah. Whenever you're working with these guys, always put the chemical starting. Okay. All right, and then we need to, now we have moles of copper sulfate. So what we need to do is use our molar mass. So what do we have left over after everything cancels out? Grams of Now, I want you to keep this in mind. Whenever we're working with problems with an equation, chemical reaction, there are always going to be 3 steps. First step is to convert the mole. Where do we start? Middle step is the ratio from the balance equation. And then the last step is to go from mole to the return. So we're gram to gram through balance chemical equation.
Chemical.
Yeah. Yeah, the middle step could be, I mean, I'm going to reword this problem in a minute here. It's something slightly different. Okay. Does everyone see where I got that set up? Okay, so we're just going to multiply here. Now I'm going to multiply everything on the top, divide by everything on the bottom, like we did in unit 1. So we're going to end up with 12.7 grams and hydrogen. Okay, so we've done a bunch of steps. Yeah. Balance the rate. This kind of balance. Then we have a mole conversion here. The reason why we convert to moles is because this ratio always counts. That's why we have to convert to moles. Then we went to the moles. All right, let's do a slightly modified version of this problem. Okay, so we're starting with 24.1 grams of the hydride again. How much water? 2 grams of water. So we're going to use the same balanced equation. Now, what the middle step is, remember the ratio, the coefficients. This time we're talking about the water, which is an 8, not a 1. So we're going to start with and this was 303, wasn't it? Copper hydride has to cancel, so it needs to go on the bottom here. Only we're working with water now, and the water coefficient is 8. Where see where I got the 8 from? The 8 is right here. So the ratio of this to that is 1. So each mole of this Okay. Molar coefficient ratio. Now that gives us moles of water. We don't want moles of water, we want grams of water. So this last step is our 1802. So we lost 11.4 grams of water. We start with the 24.1 grams of This comes from the parent table. This comes from the balance equation. So every single we call this problem it's going to have three parts.
I know, I was thinking of doing it, so.
Okay. All right. That's what I wanted to cover tonight. Now, the deal is, I want you to practice these. I want to give you some problems here. You're comfortable doing it here. You get more practice time, you get more problems. Okay? Once you feel comfortable with just doing it straight, you know, so many grams of this, how many moles of that, so many grams of this, how many particles of that, so many particles, how many moles, how many particles, how many grams. And then we can do some simple equations. Well, and let's continue to use this one with we're taking copper sulfate, hydride, and okay, so let's just come up with some problems. Are there any questions about the last problem? I got all the. Now, if you go to my. I gave you problems in the book corresponding. Problems, they're not very many. I gave you a whole boatload of problems. Right. In that zip file. In the module. Or I have it individually in the file. Okay. This unit we're doing now, this concept is called stoichiometry. Stoichiometry is the relationship between reactants and products in chemical reaction. And we just did a gram to gram stoichiometry. Started with grams, went up to grams. Okay, so let's. Okay, much work in these three problems. This problem is last from the same one. Hydride plus E gives us human hydride plus E.
Yeah. I mean,
This was a test on implants. On the 9.0. The answer you get that one is you can use set. And this is, weird thing is, see that? It doesn't come with something. It's a big, even one by 6. Right now, when the brain scans come up with mold, we look at mold, yeah. Mold in the body, 6 material, blah, blah, blah. You always make sure the roots cancel. Because if they don't cancel the cell, and that's 90% of the cell. That make sense? I want you to look at this. See if this makes sense in your mind. How can this point in the
It's just a negative part of that.
how many molecules are in there? Third.
Oh, that's less.
Watson, minus 11. So in your mind, the answer should be tiny. It's not tiny, it's just.
Yeah, okay, now that makes more sense. After you said it's 11 less, I'm like, oh, now it,
11. Oh,
yeah,
that's why I get 10.
okay. Thank you. Yeah, that makes so much sense.
Look at this. First, you want to read about that 23 and 23. I remember you being fixed.
Oh, I got it.
And that's classic. And what drugs going to do? Because that's it. And people think it's more. We're turning.
I'm always confused with email. But is it kind of that's the thing? I'm like, hello? Yes, please.
Yeah, it's really like functions.
Question. I just have one with my
This is like, you know what? Small thing, this is small. How do we go from there to so what comes out, small thing, and what? Okay,
shot.
the whole grade is set up as what 90. So that's 9 points.
Oh, yeah.
And so if you get this right, The number's right, systems are right, and the units are right. You get it. What I recommend, it's so,
Right.
Yeah,
so, you can go back. Yeah, that's fine.
Awesome, thank you.
Does that make sense?
Yeah.
This is simple. What we're going with this concept. Let's start to see if we get into the next. Next. Next up is the ratio of the
They got
and then I give you more of whatever, any, and you can go back. So always.
I got the same thing, 1.6.
It's like this, instead of grams or kilograms.
Yeah.
Basically.
Number one.
Because that's the main focus. Analysis. So you're always in a full step. First step is analysis. The next step is what's given.
So.
What's not given. And the next step.
I was like, oh, damn. I was like,
Oh.
then it goes. So if I'm three.
1.15, but we rounded up.
Oh. That, so that was things.
If we write each on paper, will you be doing that as the same?
Or you understand.
I know that certain
Or
things.
that this side on the side is a way.
I don't know how.
So like, are we doing
Some of the
that?
very. And you say,
But this. This is.
So it is.
Got it. That's what it is.
Well, that's what my calculation.
I get it. So, and that.
1.16, but it's on the calculator. That's 5 right after. Sorry, right.
11 times 10. Again, 10.
Yeah, I mean, I just don't like, okay, these things are. Oh. And white. And then, I was like slightly confused. It's just like, okay, focusing on the keyboard. No. Okay.
Yeah. Once you call for all right, everyone, on this problem. Now your lab can be a wet lab, so make sure you get it pre-op. Should be. Watching. They call them dry labs. Before we get let's go. Okay. What I want to do, rest of the night, I want to introduce balancing equations. And then I'm going to do the whole fun. Does everyone work through this problem? All right, so let's